Okay, a little help here on tree diagramming and probability models. So what I have here is a spinner and a die, and what I'm going to do is play a little game. I am going to spin a spinner and see what I get here. I get green, and I'm going to roll the die. I roll the die, and I get 1. I got a green and 1. The question is, how many different things can happen there when I play that little game? Now, the fundamental counting principle from previous concepts here in a probability course would show that there's 4 options here for the spinner. So the spinner gives me 4 options, and the dice, as the dice here has 6 options. It's a 6-sided die. So fundamental counting principle would tell me that I have 4 times 6 different outcomes that can happen here, or 24 different outcomes that can occur. Now, in order for me to draw a tree diagram, what I need to do is I need to list these outcomes. So there are 4 outcomes on the spinner represented by purple, green, red, and orange. And so since there are 4 outcomes there, I need to start my tree diagram with really 4 things that come off of my tree. So I'm going to have 1, 2, 3, and 4. Okay, and I'm going to label those here. I can get purple, I can get green, I can get red, and I can get orange. Those are the 4 things that can happen. Now the probability that they each happen, now each probability is equal here because they're all the same size spacing here on the spinner. So I have a 1 in 4 chance for each of these. So I would label all of these little branches here as a probability of 1/4. I have 1/4 on all of these. 1 in 4, 1 in 4, 1 in 4. All right. Now, the next thing is I have to remember that this tree diagram that I've begun is starting to tell a story. It's saying once I spin that spinner here, the second I spin the spinner, and I'll do it one more time, I'll spin the spinner to see what I get, and I got green again. Okay, well, in this story down here, the tree diagram, I have begun to travel the road of the green. And so what I've actually done here is I have actually traveled this path right here. Sorry about that. I am traveling this path in my story right now. I'm here. Okay, now I haven't rolled the dice yet, but now that I'm sitting here on this green, I need to decide what can happen next here in this game. And the next thing I'm going to do is I'm going to roll the die. So when I roll the die here, I'll do it one more time, I get a 6. Now there were 6 things that could have happened there. And so when I am on my tree diagram, I actually have to draw 6 outcomes off of this green, because there are 6 roads I could have traveled. Okay, and this tree diagram is going to have a lot of things in it here. Okay, now the 6 outcomes are just the numbers 1 through 6. 1, 2, 3, 4, 5, and 6. Okay, there are 6 things that could have happened after I reached this green spinner spin. Okay, and the thing that I actually traveled on, the thing that actually occurred here, was that I spun a 6. So I have actually continued, from the green spin on the spinner, I continued down this path right here, because I ended up at this spot in the game right here. I rolled a green 6 and a 6. I spun a 6. I should say I spun a green and I rolled a 6. Okay, now that was the one outcome that occurred up here. Okay, that's the one thing that occurred. Now, since there are 6 outcomes on the die, every time I look at the probability of all of these numbers happening, the probability of every one of those lines is 1 out of 6. This is a 1 in 6 chance that I get a 6, a 1 in 6 chance I get a 5, a 4, a 3, a 2, and a 1. Now, to find um, the rest of the tree diagram, what I really would have to do is I would have to repeat this process here. This 1 through 6, I would have to draw 6 more lines coming out of each one of my spins. Now, the fact that I have so many outcomes here, okay, the P, if I rolled a purple, I'd have another spin be 1, 2, 3, 4, 5, 6. Okay, and to kind of make this process speed up a little bit, what I want to do is I want to actually just kind of copy and paste this and maybe rotate it because I have 6 outcomes that occurs on each of these things here. So as far as the orange goes, if I spun an orange, I would have 6 outcomes here. Okay, and the same thing goes true if I would have spun a red. So as you can see, this tree diagram gets kind of big and really crowded. And the reason it gets really crowded is because there are 24 different lines here that represent all of the outcomes that could occur. Because I could get 4 things on the spinner, 4 options, and each one of those options has 6 branches that come off, and each of those 6 branches represents my die roll of 1, 2, 3, 4, 5, and 6. And there are 24 lines. If you counted all these up, there's 24 total lines here that occur. And so when I start to build a probability model, talking about what all these probabilities are, okay, there's a lot of different things that can happen in this chart. There's 24 separate items that can occur. But to get my end probabilities, to get what is on the end, what I need to do is I need to multiply as I travel through this tree diagram. And so there's a 1/4 chance I land here on green and a 1/6 chance that I land here on 6. So I need a 1/4 chance of green times a 1/6 chance of rolling the 6 to get a final probability of 1 out of 24. And I would have to go through and do that for every outcome in this diagram. Now this is an easier example, but it's a good basic example of how to draw a tree diagram and the fact that you should multiply through a tree to get the end probability of that event occurring.